The subject is Engineering Chemistry 1. It belongs to first year BE E&IE department. The course code is 18EI103. It is 4th unit. The topic of the unit is Nanomaterials for Sensors. We are going to discuss about nanomaterials. What is meant by nano? The word means the size in the range of 10 to the power of minus 9. Nano means size in the range of 10 to the power of minus 9 meter. So nanometer means 10 to the power of minus 9 meter. Nanoparticle means any particle whose size range lies in 10 to the power of minus 9 meter is called as nanoparticle. It refers to collection of atoms bonded together and their structural radius lies in the range of less than 100 nanometer. Then it is called as nanomaterials. When a substance is converted into nanoparticle, it shows interesting physical, chemical, biological and electronic properties. These properties are interesting and advantageous in our life. Now we will discuss about the classification of nanoparticles. Based on dimension, nanoparticles are classified into 4 types. They are 0 dimension, 1 dimension, 2 dimension and 3 dimension. 0 dimension means nanoparticle whose dimensions are all found to be in dimensional range. That is, all the dimensions are found to be in nano range. That is called as 0 dimensional nanoparticle. Example: quantum dot, carbon quantum dot, graphene quantum dot, carbon nano dot. 1 dimensional nanoparticle, which means 1 dimension alone exists outside the nano range. That is called as 1 dimensional nanoparticle. Example: nanorod, nanowire, nanotube, etc. 2 dimensional nanoparticle. Here in nanoparticle only 2 dimensions exist out of the nano range. Example: plate like structures such as graphite, nano coating, nanofilm, etc. 3 dimensional nanoparticle. Here all the dimensions exist outside the nano range. So it is called as 3 dimensional nanoparticle. Example: bulk powders, fluorine, bundle of nanowires, multi-nano layers. Next, we are going to discuss about the properties of nanoparticle. Nanoparticles possess high surface area relatively to volume. They possess low melting point. That is, when a chemical substance is converted into a nanoparticle, they show a tremendous change in their melting point. They are super hard materials. Nanoparticles are chemically reactive. They confine electron to produce quantum effects. That is, they show change in materials with respect to optical, electrical and magnetic properties. They enhance solar absorption. They possess high surface area to volume ratio. Nanoparticles being one part is hydrophilic, other part is hydrophobic. This dual nature enables them to find its application in drug delivery. Nanoparticle possess absorption and emission properties due to transition of electrons between the 2 states. And next one is applications. Due to the unique physical, chemical and optical properties, nanoparticles find extensive applications. Their applications are numerous. Here I will tell a few examples related to biology and environment. In medicine, nanoparticles are used as nanodrugs for the treatment of cancer and tuberculosis therapy. They also function as medibots to release cancer drugs to a particular area. Nanoparticles destruct tumor cells. It involves a slow and selective release of drugs to the target organs. This enables the drug amount, and this application enables the pharmacist to give low dosage of drug which works in an efficient manner. It also repairs neurological damage. Next, application of nanoparticles in environmental areas. It is used as a catalyst, that is, it acts as a catalyst in degradation of toxic compounds. It is used in water purification. Nanoparticles are used in water purification. Nanoporous membrane enable them to remove the total dissolved solid and toxic compounds and color producing compounds from the water. It is also used in fabric industry. Nanoparticle, when embedded in the fabric, it acts as a stain repellent. It also helps to prevent the bad odor in clothes. It is used in automobile for fuel consumption. Nanoparticle is embedded in many materials to provide a strong material which is used as a building material in many automobile industries. It is used in energy sector to reduce the cost of photovoltaic cell. Because nanoparticle enhances the solar absorption, it also used in photovoltaic cell to decrease the cost and increasing the efficiency. This efficient nanoparticle can be synthesized by two types of approach. One is top-down approach and bottom-up approach. Top-down approach, and next one is bottom-up approach. This top-down approach refers to slicing or cutting off of bulk material to get nano size particle. In the case of bottom up approach, it refers to build up of materials from bottom by atom by atom, molecule by molecule by molecule. Here the starting material should be in solid state. Here the starting material shall be either in liquid or gaseous state. This can be prepared by physical processing methods that can be classified into two types. They are mechanical method, another one is lithographic technique. Mechanical method means it involves cutting, etching, grinding, ball milling methods. Lithographic technique involves photolithographic technique, electron beam lithography. In the case of bottom approach method, it involves physical and chemical processing method. So here we are using two types of method: physical vapor deposition, chemical vapor deposition methods. So PVD, which means physical vapor deposition. In this method, it involves sputtering, plasma arcing, laser ablation, chemical vapor deposition. It is abbreviated as CVD. Here it involves electrolytic deposition, sol gel method, pyrolysis. Okay, what are the advantages of top-down method? This method enables us to produce nanomaterials in large scale production. Chemical purification not required. Not. And what are the advantages of bottom-up method? So using this method, we can produce materials with ultra fine particles, nanoshells, nanotubes prepared, narrow size particles are distributed. Narrow size particle means when we synthesize nanoparticles by bottom up approach method, the particle size distribution is found to be in the range of 1 to 20 nanometer, that is narrow particles. 1 to 20 nanometer is possible. And what are the disadvantages of these techniques? Here, broad size distribution of particles. Here particles will be randomly distributed up to 10 to 100 nanometer. So imperfection are introduced. The technique is expensive. And what are the disadvantages of this technique? So here large scale production is difficult. Large scale production is difficult. The nanoparticle prepared by this method consists of impurities. So this is the comparison between the top down and bottom up method. An important nanomaterial we are going to discuss is carbon nanotube. Carbon nanotube. So what is carbon nanotube? Carbon exists as nanoparticle in tubular form called as carbon nanotube. How carbon nanotube is formed? Graphite sheets is rolled, edges are linked together to form a tubular shape that is called as carbon nanotube. The carbon nanotubes are aligned in the form of rope. They are held together by weak van der Waals force. This carbon nanotube can be classified into two types. They are single walled carbon nanotubes. This can be abbreviated as SWNT. Multi-walled nanotubes, MWNT. One tube of graphite are rolled into sheet and edges are joined together to form single walled nanotube. So it consists of one tube of graphite its diameter is found to be in the range of 2 nanometer. Its length found to be in the range of 100 micrometer. Single wall nanotube possess excellent electrical properties. The single wall nanotubes are classified into three types. They are armchair nanotubes, zigzag nanotubes, chiral nanotube. This armchair shaped single wall nanotubes possess excellent metallic property. The zigzag and chiral shaped single wall nanotube possess semiconducting properties. Multi-layers of graphite sheet are rolled into sheet. Edges are linked together to form multi-wall carbon nanotubes. It is abbreviated as MWNT. These multi-layers are held by weak van der Waals force. So multi-wall nanotubes consist multi-layers of graphite. It possesses both metallic as well as semiconducting properties. It is used to store fuels, that is methane or hydrogen. These nanomaterials or nanoparticles can be synthesized by various methods. Now we will discuss about two methods. They are laser ablation method and next one is chemical vapor deposition method. Laser evaporation method or laser ablation method. Graphite along with the cobalt and nickel as a catalyst is kept in a quartz tube. The quartz tube is kept in a furnace along with the heating element. One side of the quartz tube is connected with water cooled copper collector. The other side of the quartz tube is connected with the laser light and helium gas. Here, helium acts as a carrying gas. The role of carrier gas is to sweep the particle towards water cooled copper collector and get condensed to form the corresponding nanoparticles. Graphite along with catalyst such as cobalt, nickel is placed inside the furnace. It is heated at high temperature of about 1200 degrees centigrade. When laser light is passed due to high temperature, the particles are evaporated. Carrier gas, which is an inert to the reactive substrate, sweep the particle towards water cooled copper collector. They get condensed and carbon nanotubes or carbon nanoparticles or any nanoparticles will be collected in the quartz tube. Next method is chemical vapor deposition method. A solid substance is converted into vapor and deposited on the surface. That is called as chemical vapor deposition. In chemical vapor deposition, here the substrate is placed along with the catalyst, iron, cobalt, nickel nanoparticles as a catalyst. It is kept on a porcelain which is impregnated with a nanocatalyst. One side of the quartz tube is connected with a vacuum pump and other side is connected with an acetylene gas and nitrogen gas. Here nitrogen acts as a carrier gas. This acetylene gas reacts with the substrate at high temperature, probably 1000 to 1200 degrees centigrade. As a result, the chemical vapors are deposited on a solid substance to get a new material. The heating involved in this method can be classified into two types. They are hot wall CVD and cold wall CVD. Hot wall CVD means heating is done surrounding the material. In the case of cold wall CVD, heating is done inductively on the material and cool air or cool water is circulated outside the furnace. The nanomaterials prepared by the chemical vapor deposition are more economical. It is free from defects, impurity It can also be used for large scale production. So far we have discussed about what is meant by nano, how nanoparticles are classified based on the dimension, what are the important properties of nanoparticles and applications of nanoparticles, how to synthesize a nanoparticles. We have differentiated top-down approach and bottom-up approach method. What is meant by carbon nanotube? What are the classifications of carbon nanotube? We have compared single wall carbon nanotube and multi-wall carbon nanotube. How to synthesize the nanomaterials or nanoparticles by two methods, laser evaporation method and next one is chemical vapor deposition method. That's all for today. Thank you.